All right, I'm back. You might hear some crackling in the background because someone's taking the exam. Okay, so let's talk about this one. So number one, the issue that people have is that they hate fractions. Everybody hates fractions, but fractions in every part of our lives. Like I was trying to figure out how to healthily eat this strawberry cream pie. So I cut it into 6 pieces. So every night I can have a 1/6 of a piece, right? So we got to deal with fractions all the time. So, but I do let the students know how to get rid of fractions in equations, and it only works with the equations, okay? So if I have 3 over 10x plus 7 over 10y is equal to 7 over 5. Because it's the equation, and I know it's the equation because of the equal sign, okay? What I'm gonna do is I'm going to look at the denominators, 10, 10, and 5, and saying, what's my LCD? And my LCD is 10, so what I'm gonna do is I'm gonna multiply each term by 10, okay? And when I multiply each term by 10, the 10 cancels out, the 10 cancels out, the 5 will reduce this 10 to 2. So now my equation is gonna be 3x plus 7y is equal to 14. Look, boom. I got rid of all the fractions. Now, if you're wondering how is this possible? Well, I actually did not change the value of the question. The question is exactly the same. The equation is exactly the same value. So if you were to, let's say, plug numbers in, right? You will get, if you plug a number in for x and solve for y, on this equation here, and then did the same thing with this one, you'll get the same value for y. Okay, so these two are essentially the same exact lines. Okay, now the LCD only works again with equations. All right, so now that I have that, I'm going to write down the other equation, which is 3x plus 2y equals 34. And let's see what I want to do here. It just tells me to solve the system of equations. So I can do whatever I want. I can do substitution or elimination. For me, elimination is less thought to it, less thinking to it. With substitution, if I think about substitution, like if I was to solve for x here, right? That means I got to divide everything by 3 at some point. I'm going to get a fraction here and a fraction here. Okay? All right. If I was to, let's say, solve for this y, I'll have to divide by 7 at some point. Well, this is going to become a fraction. This is not. The 14 would not. But still, I got to deal with a fraction. Okay? And then if I think about this x, I got to divide by 3. These both would be fractions. And if I was to solve for this y here, I got to divide by 2. This won't be a fraction, but this will. Okay? So what I like to do, so with substitution, you always want to try to solve for one of the variables so that I wouldn't have any fractions because we love fractions so much. All right. So what I'm going to do is I'd rather do elimination. It's less thought. And the way I do elimination is if you think about which one you want to get rid of. You want to get rid of x, or do you want to get rid of y? It's your choice. It's whatever you want to do. All right, so for me, I'd rather get rid of the x. So I need the coefficient, meaning the 3, to be the same, but I need one to be negative, one to be positive, so when I add it, it'll go away. So what I'm going to do is I'm going to multiply, it doesn't really matter which one. Let's say I multiply the top one by a -1. If I do that, then I get a negative 3x minus 7y is equal to negative 14. While the bottom one is just 3x plus 2y equals 34. Now, if I add these two equations, right? Negative 3x, positive 3x gives me 0, so that goes away, right? Negative 7y plus 2y will give me a negative 5y. And then negative 14 and plus 34 will give me 20. So therefore my y is equal to negative 4. So now that I got y is equal to negative 4, I gotta find my x. Okay, so to find my x, I gotta plug it into one of my equations. So I'm gonna plug it into the equation that that I didn't have to screw with fractions. So I would choose the second one, which is 3x plus 2y equals 34. And I know that y is equal to negative 4. So I'm going to have 3x plus 2 times negative 4 is equal to 34. So I got 3x minus 8 is equal to 34. So add 8 over. So 3x is equal to 42. So x is equal to 14. Okay, so I got that. So when I'm doing the system of equations, so this is an equation of a line. This is also an equation of a line. Okay, so in other words, if I have two lines, my solution would be where it crosses each other. So in this case, where does it cross? It crosses when the x value is 14 and the y value is negative 4. So therefore, this point is 14, negative 4 would be my answer of where it crosses. Okay? So that's how you do that part. And then last but not least, number 25. Now, number 25 is asking you to do a system of linear inequalities. So that means it's also including shading, okay? So when I'm doing that, again, same thing. Let's use a red line. So this is telling me it's dotted. And this is also telling me that it is dotted. So I'm gonna have a dotted red line and a dotted blue line, okay? So let's start with the red. The red is going to be y is equal to 2x minus 4. So y-intercept is 0, negative 4, and my slope is 2 over 1. So I got to go up 2 and right 1. So 0, negative 4, up 2, right 1. Okay? So up 2, right 1. So I have a dotted line that goes something like this. Okay? All right, so if I was to test this one, I can still test 0, 0, okay? So as long as 0, 0 is not on the dot, or on the line, I'm good, okay? So if I was to test 0, 0, then I have is 0 less than 2 times 0 minus 4. So is 0 less than 0 minus 4 is 0 less than negative 4. So do I have less money when I have $0 in my pocket, or do I have less money when I'm $4 in debt? Right? So this is a no. Right? So 0 is not less than negative 4, so this would shade in this direction. Okay? So now I go to the blue one. This is y equals x plus 5. It goes through 0, 5. That's my y-intercept. And my slope is going to be 1 over 1. So I got to go up 1 and right 1. So I got to go 0, 5. I got to go up 1, right 1. Up 1, right 1. Okay? So I have this dot here. And this is also dotted. I can still test 0, 0. Okay? So now I want to test 0, 0. Is 0 greater than 0 plus 5? Is 0 greater than 5? And the answer is no as well. Because do I have more money if I have $0 or $5 in my pocket, right? So I have more money if I have $5 in my pocket. So therefore 0, 0 is not it. So I got to shade this way. Okay, now what you're noticing is that I have 4 regions, right? I have this region here that has nothing shaded. I have this region here that is only shaded in red. I have this region right here which is only shaded in blue. Now, this region right here, if you notice, is actually shaded twice. So if I extended the red out, I would still be shading this way. So if you notice that this region right here, right, is shaded twice. So that would be my solution. Okay? So that's how you go about doing it. You ignore the rest of it because it's only shaded once or none, where shaded twice would be your solution. All right? Well, I hope this video helps, and let me know if there's anything that you have questions about. Thanks. See ya. Bye.